Assalamualaikum. Today I'm going to present about our group assignment. We from University Tun Hussein of Malaysia, Faculty of Electrical and Electronic Engineering. Our title for this project is PID Controller Designed for Speed Control System. The code subject is BEV 30503. We are from the group 6 section 2. The name of this group member is Alif Nazmi bin Ahmad Tamizi, Ahmad Irfan bin Rosli, Fidaus bin Talib, and Muhammad Izzat Imran bin Nordin. Okay, we start first with preface.
Assalamualaikum warahmatullahi wabarakatuh. This report has been writing in December 2020 in Control System Group Assignment in University Tun Hussein of Malaysia. We thank for the Prof. Maria Dr. Shahul Aizam bin Zulkifli for the guide which our mini project. This project is about design our block diagram for P, PI and PID and simulate it in Simulink. My profile of teammate is member number 1 is Alif Najmi bin Ahmad Tamizi. The number matrix is DE200112. Member number 2 is Fidaus bin Talib. The number matrix is DE200103. Member number 3 is me, Muhammad Izzat Imran bin Nordin, DE200066. And lastly is member number 4 is Ahmad Irfan bin Rosli. The number matrix is DE200084. Thank you for
Assalamualaikum warahmatullahi wabarakatuh. My name is Alif Najmi bin Ahmad Tamizi, DE200112. So now I will present about our project introduction for PID controller design. So a proportional integral derivative controller PID controller or term controller is a loop mechanism employing feedback that is widely used in industrial control system and a variety of other applications requiring continuously modular control. A PID controller continuously calculate an error value as the difference between a desired set point and measured process variable and applies a correction based on proportional, integral, derivative term and the net PID respectively, hence the name. So in practical terms, PID automatically applies an accurate and responsive correction to a control function. An everyday example is the cruise control on a car where ascending a hill would lower speed if a constant engine power were applied. The controller PID algorithm restores the measured speed to the desired speed with minimal delay and overshoot by increasing the power output of the engine in controlled manner. So this paragraph is talk about the first theory and same as this paragraph. So this is as example of the block diagram of PID controller. So in this model, term P is a proportional, and for example, if the error is large and positive, the controller output will proportionally large and positive, taking it into account the gain factor K. Using proportional control alone will result in an error between the set point and the actual process value because it requires an error to regenerate the proportional response. So if there is no error, there is no corrective response. And for term I, for example, if there is a residual SP PV error after the application of proportional control, the integral terms seek to eliminate the residual error by adding a control effect due to historic cumulative value of the error. So when the error is eliminated, the integral term will cease to grow. So this will result in the proportional effect diminishing as the error decrease, but this is compensated by the growing integral effect. So for the term D, it is sometimes called anticipatory control. This is effectively seeking to reduce the effect of SPPV error by asserting a control influence generated by the rate of error change. The more rapid the change, the greater controlling of damping.
Assalamualaikum. My name is Firdaus bin Talib, and today I'm gonna present about literature review for this project. The title of this literature review is DC Motor Control Speed by using PID controller. This literature review published in 2019. Okay, so we start first with introduction. Speed control system is the most common control algorithm used in industry and has been universally accepted industry control. One of the applications used here is to control the speed of DC motor. Controlling the speed of a DC motor is very important as any small change can lead to instability of the closed loop system. The aim of this thesis is to show how DC motor can be controlled by using PID controller in MATLAB. The development of the PID controller with the mathematical model of DC motor is done using automatic tuning method. The PID parameter is to be tested with an actual motor with the PID controller in MATLAB. In this paper, describe the result to demonstrate effectiveness and the purpose of the PID controller produce significant improvement, control performance and advantage of the control system DC motor. Next, method of DC motor speed control. There has two methods. First method is armature control method and the second is field control method. Field control method is the field current or current through stator is varied to control the speed of the motor. Armature control is the method that the armature voltage is varied to control the speed of the motor. Okay, so we go to the DC motor. This is the circuit of the DC motor. We have resistance, inductor, and load. This is voltage. Okay, transfer function equation. Transfer function equation of feedback control system. The torque generation generated by the DC motor is proportional to the armature current and the strength of the magnetic field. In this example, we will assume that the magnetic field is constant. Therefore, the motor torque is proportional to only the armature current by a constant factor as shown in the equation below. PID controller. PID circuit is often utilized as a control feedback loop controller and is very commonly used for many forms of servo circuit. PID circuit represent the three control settings of PID. As an example, P, I, PI, or PID. Okay. The purpose of any servo circuit is to hold the system at the predetermined value for long period of time. The PID circuit actively controls the system so as to hold it at the set point by generating an error signal that is essentially the difference between the set point and the current value. The three control relate to the time-dependent error signal, and its simplest this can be thought as follows. Proportional is dependent upon the present error. Integral is dependent on the accumulation of past error, and lastly, the derivative is the prediction of the future error. So, we go to the PID function. PID is a control method or mode that has three functions or variables. The proportional action dampens process response. The integral correct or drop is the difference in process variable between the process set point and the actual process output. The set point is the desired value of process variable. The derivative minimizes the amount of overshoot and undershoot. Mathematically, the PID controller can be expressed where U is the control variable and the E is the control error. The control variable is thus a sum of three terms: proportional, integral, and derivative. Okay, so we go to the next part, which is the characteristic of PID controller. We have KP, KI, and KD. So for the KP, the rise time is decrease, overshoot, increase, settling time, small change, and SS error is decreased. For KI, decrease, increase, increase, decrease. KD, small change, decrease, decrease, no change. This result we get from the simulation. So for the design requirement, settling time less than 2 seconds, overshoot less than 5%, and lastly, steady state error less than 1%. So this is the simulation result of the DC motor that produced by this literature review by using PID controller. So this is the circuit of the of the model. Okay, this is model of DC motor, and this is the graph that have produced by the circuit. And this is a closed loop response of DC motor. A peak amplitude we get 0.0196, and this is the graph. Okay, DC motor with P control PID. We get the KP is 64.43 and rise time 0.132 and maximum overshoot 17.2%. Settling time is 0.685 second and peak amplitude is 1. So this is the graph of P controller. Next, if we go to PI controller, the KP is we get is 64.42 and KI we get 10.49. For the rise time 0.132 second and for KI we get 0.163. So for the maximum overshoot we get 17.2 for the KP. For the KI we get 1.83%. For settling time 0.665 for the KP and 0 second for the KI. Peak amplitude all same, both same, which is 1. Next, PID controller before tuning. We have KP, KI and KD. KP 61.09, KI 186.6 and KD 4.36. The rise time is 0.132, 0.163 and 0.177. The maximum overshoot is 17.2%, 1.83% and lastly 6.98. For the settling time 0.665, 0 second, 0.794 second and the peak amplitude 1.07. So this is the DC motor PID controller after tuning. Okay, so the KP we get as 17.45, the KI 48.49, KD 1.507, rise time 0.132, 0.163, 0.528 and go on. Okay. So the conclusion for this literature review. Based on the present literature review, author concluded that PID controller is very effective and powerful controller that has been controlled approach in order to sustain speed of the motor. The parameter value of PID controller are set up by the tuning method. Still, there is much scope in improving the PID controller design to make it more simple. The application of DC motor and drive have used in recent years in the appliance industry and the automotive industry. This paper has discussed aspects of DC motor speed control by using PID controller. To examine the speed control of DC motor, the software package MATLAB was used to design the block diagram and run the simulation. This paper studied the PID controller for the DC motor control speed system. For better speed control application, DC motor can give a better performance than induction motor and AC. So, lastly, graphical representation of program give clear understanding about the structure and data flow. It is better for control application while MATLAB is better for data manipulation. I think that's all for me. Thank you.
So next part is I will present about the problem elaboration for this project. So the first is the methodology. So first step, we make some research about PID controller and DC circuit in control system. And second, make introduction and literature review and search all the components that need to be in the system. And the fourth is derive the mathematical model and block diagram for this system using MATLAB software. And next is combine all the result that we get and put it in the table. And next is discuss the result that we get and put it in the report and do the conclusion of the project. So finally make the video explaining the report and make the video explaining the simulation finding. So this is our mathematically modeling for parameter. So this is a parameter DC motor. Okay, now we'll discuss about our DC circuit equation. So this is our equation for DC circuit, and then where E is the back of EMF, or since back EMF is directly proportional to the angular velocity of the motor, so we will get the equation E is equal to KB theta. and the since torque is directly proportional to the current, so T is equal to KA IA, and the substitute equation 2 and 3 into 1. So the final equation we will get VA is equal to T RA minus SLA multiply S plus KB KA multiply S theta S and divide by KA. So since the moment of inertia and viscous friction is given, so T is equal to D squared theta divided by dt squared and plus B d theta divided by dt. So next, convert to the frequent domain, so we will get T is equal to Js squared theta S plus Bs theta S, and then substitute equation 5 into the equation 4, so VA is equal to Js squared theta S plus Bs theta S and RA plus SLA plus KBKA S theta S and divide KA. So to find the total moment of inertia and viscous friction, so J total is equal to this, that is 0.244 kg m squared, and for B total the final answer we will get 0.0035 nm as radian negative 1. So our transfer function, first step we will get this equation, and then we simplify, then we get this equation and put all the information here. So the final answer we will get the transfer function is 1.28 divided by 0.0295 as the power of 3 plus 2.7332 as power of 2 and plus 1.6392 s. So after we get this transfer function equation, we have to put it in the transfer function blocks for our simulation. So this is the example of our simulation block diagram. So that's all for me. Thank you.
Assalamualaikum. My name is Fidos bin Talib, and today I'm going to present about the last part of this project, which is conclusion. Okay. In the industry, PID control and edge bearings are widely employed. They can be used in a varieties way. P controller can stabilize only first order unstable process. PI controller can be used to avoid large disturbance and noise present in during operation process. Whereas PID controller can be used when dealing with higher order capacitive process. The comparative study of P, PI and PID controller is carried out in which PID controller give good response than any other controller. Typically, these two parameters are odds with one another, making the design more difficult. PID is chosen since it offers both of these benefits at the same time. The goal of this recitation was to describe how to successfully use PID controller in a future work and to cover practically all elements of PID controller. So for this project, we have to conduct a simulation by using a software, and we decided to use a MATLAB to run our simulation. We have two-step response, which is 900 RPM and 1500 RPM by using different methods. As an example, we use manual controller, automatic controller, and without controller. We also use different types of controllers such as P, PI, PD, and PID. All of these have different circuits, and in the simulation, we get different results that show by the graph from the simulation. Lastly, this project gives us more knowledge and information about MATLAB, and also we learn something new about this type of controller. As a student, we also learn how to work as a team and conduct this project and submit by the due date. I think that's all for me. Thank you.